Hi, my name is Luyren, and here's a quick stencil tip. Learn the Image API. The Image API refers to blocks that display plain images. They perform better than the drawing blocks, you can have a greater number of images on screen than actors, and there are several ways to manipulate those images. They can also be used anywhere without restrictions, unlike the drawing blocks, which are confined to the drawing event. The Stencilpedia article covers the basics and is a good starting point to learn images, so make sure to check that as well. It also showcases examples of what you can achieve with images. Before we begin with the tutorial part of the video, let me show you what I've been able to create using the Image API. With introductions out of the way, let's get started. In exchange for performance and versatility, images aren't as straightforward as the drawing blocks. And here's where the concept of images and image instances comes into play. To explain those, let me start with something you should already be familiar with. When working with actors in Stencyl, you first create an actor type, with animations, behaviors, and collision settings. You then place that actor on the scene designer, or create it through code when appropriate. Each actor you create or place in the game is an individual instance of that actor type, inheriting all its properties. They can be changed individually, from its behavior values to its dimensions, position, and rotation. Some changes are still universal, affecting all actor instances, such as removing or adding animations, the actor event code, changing collision boxes, changing the physics settings, or changing the actor's group. Images work in a similar fashion. Images are your canvases, what you manipulate by adding pixels, drawing text or other images on top of, tinting with a color, and many other functions. Image instances are like physical copies of the image, which you can rotate, make bigger or smaller, and, most importantly, display in-game by attaching them to a layer, actor, or to the screen. When working with images, you need to first create or retrieve an image from something, create an instance of that image to be displayed, and then attach the instance to where you want it displayed. That is the basic process, and if you understand this, you can start experimenting with images. Like actors, you need a way to reference your images and image instances in your code. You can achieve this by creating image and image instance attributes. They will store your image and your instance, and you will use the attribute blocks to perform operations with them. Since lists and maps can hold any value type, you can store your images and image instances in those as well, so keep that in mind. If you don't create attributes to store your images and image instances, you won't be able to change the image or remove an image instance that's attached to something, since there's nothing to reference them, so make a habit of always creating the attributes to hold those values. Now that we have our attributes, we can create an image. Note that the image blocks can be used anywhere, unlike the drawing blocks, which are restricted to the when drawing event. Since I just want to create a single image, I'll use a key press event. Creating an image means setting the image attribute we created to an image, which you can reference later. All the image blocks can be found under Images in the palette, and the blocks to create an image are under the Images tab. Let's go over each one. The blank image block creates exactly that, a blank image, with the specified dimensions. You can think of it like setting up a canvas before you start painting. Since it's a blank image, there's nothing to see if you attach that image as is. The copy of image block creates a copy of an image. Changing the copy won't affect the original. The part of image block gets part of an image to create a new image. You specify the starting x, y point of your part and the width and height of the part of your image. The copy of image at scale block creates a copy of an image and changes its scale with a percentage. Setting the width and height percentage to 200 would create a copy double the size of the original. Here you can see the difference between the smoothing and no smoothing setting. From the game images are images that represent the current state of your game. You can get the entire screen as an image, much like taking a screenshot. This takes time and may freeze your game for a split second, so be careful when you use it. For example, using this block in an update or drawing event without any condition attached to it will surely tank the game's performance. Instead, use a custom event that you can call as needed or a condition that ensures it executes only when needed. You can get the image of an actor that exists on the scene. This will get the image of the actor's current state, meaning its current animation frame. It does not, however, take into account the actor's rotation, actor effects applied to it, and scale from the grow block. Changing the actor's animation or frame also won't affect the image you got from this block previously. A very important warning regarding actor images. If you set an image attribute using the actor's image directly, this acts as a pointer to the actual literal image of your actor instance at the moment you stored it. What that means is that any change you make to the image attribute will happen on your actor's graphics as well, specifically to the animation frame you stored in the attribute. In this example, that frame of the green animation is now permanently filled with yellow, while the red animation frame is still normal. To prevent that, use the copy of image block combined with the image from actor block. This is only important when changing images, so keep that in mind. From external sources are images outside of the current game state. First, there are images from file. These are images you can add to the extras folder in your game. To add external images, go to Tools, Workspace, View folder for this game. Create a new folder called Extras, all lowercase. and drop your image files in them. The Extras folder can also hold other file types, and with extensions or code outside the regular blocks, you can retrieve these external files as well. When using the image from file block, you need to specify the file name up to the extension. With image from actor, you have the downside of having to create or retrieve your actor from the scene, but the upside that an actor has animations with multiple frames. Keep that in mind when selecting which to use. Unlike actor images, you don't need to worry about using the copy block to avoid permanently altering an external image. The Load Image from URL block visits a page online, and then retrieves an image through its The Image block. However, you can't visit any URL and get an image, probably due to permission settings. You likely need your own URL with specific settings that enable images to be retrieved. In short, only use this block if you know what you're doing. If this changes in the future, I'll either pin a comment or update the video description with the appropriate information. Images from external sources have a special behavior when you are making games on higher scales, using high-resolution assets. By default, any game made in Stencyl starts with high-res assets enabled. You can check them under Settings Advanced. In your target settings, you can see all the asset scales available, as well as the current game scale. Here I'm using 2x scale. With all these settings, if you get an external image, the image size is kept, regardless of the game's current scale. If you want to account for multiple scales, you have to add one image per scale size in the Extras folder, and adapt your code to get the correct image. You can use the Game Scale block under Game Screen for that, either through if statements or naming your images in such a way that the game scale information is included in its name. If you remove all the scaled assets from your target, or remove all the other scales from your game, the external images will be resized automatically to the appropriate scale. Converting images can convert an image to text, and that text back to an image. The most important use I found for this is in case you want to save an image. When using game attributes, images can only be stored in lists or map game attributes, and even then, if you try to save your game with those values, it will crash. By converting your image into a text, you can safely store your image in a text, list, or map game attribute, either for later use or when saving the game. Both of these operations take time, so use them sparingly. Last is the auto-scaling setting. This is enabled by default and makes all your images automatically scale with the game. On 2x scale, this example uses the 64x64 scaled up pixels for its size and drawings, resulting in an actual image of 128 by 128 pixels. If you disable it, images will ignore the game's scale. Now, the 64x64 image will use actual pixels for its size and drawings. For this setting to make a difference when disabled, you need high-res scaled assets enabled in your game. It also only applies if your game is using a scale greater than 1. This is useful if you want to manipulate an image regardless of the current scale, especially on mobile games, where the scale can vary from device to device. Once you've created an image, you then need to create an image instance out of it. Like with the image previously, creating an instance involves storing the instance of an image into an attribute. All the blocks related to image instances are in the Show Images tab. To create the instance, use the Instance of Image block when setting your attribute. You can't create an image instance without using an image attribute. In this case, you won't be able to change the image, since you have no attribute to reference it, but you can still use the blocks that affect the image instance. For the instance to appear in-game, you need to attach it to something, with 3 main locations. Attaching to an actor makes that image's position relative to that actor. X0, Y0 of the image will match the actor's position. You can also specify if the instance is attached to the front or back of your actor. This is the same as the actor space setting in the drawing blocks, including matching the actor's layer, with the difference that its angle matches the actor's automatically. Attaching to a layer makes the image's position relative to the scene. X0, Y0 of the image will match the X0, Y0 in the scene. You specify the layer to attach to, and if it's attached to the front or back of the layer. This is similar to the scene space setup explained in the drawing video. Attaching to the screen makes the image's position relative to the camera. X0, Y0 of the image matches the position of the camera, just like the screen space in the drawing blocks. It's also similar to anchoring actors to the screen, which uses the HUD layer above everything else. The location used to attach the image to is called its parent. To remove an image from its parent, use the Remove Image from Parent block. Once removed, the image instance will disappear. Be careful when removing instances though. If you remove an instance from a parent when that instance isn't attached to anything, you'll get a null reference error. Make sure you are always removing something that is attached to a parent. What happens when you attach the same instance multiple times? In this case, you are effectively changing the parent of your instance. What if you change the value of an instance when it is already attached to something? In this example, I first attach these instances to the screen. On another key press, I set them again and attach them to the layer. As you can see, the previously attached instances lost their reference. If you remove your instance attributes from their parents, you only remove the last instance attached, leaving your previous instance forever attached to the screen. Changing the image will no longer affect the instance left behind. This happens even if you set your attribute to an instance of the same image. Keep that in mind and manage your attributes accordingly. All the other blocks to manipulate an image instance work in the same way as the equivalent blocks for actors. A couple of notes. The XY position and direction of the instance is relative to its parent. All the Z-order blocks move the image relative to its parent. You can't switch layers for an image instance, but you can switch the order within the parent to organize multiple images attached to the same parent. When getting an image instance's width or height percentage, the value returned is in relative format. 1 means 100% or the original size, and 0.5 means 50% or half the size. To apply an effect to an image instance, use the same effect blocks for actors, located under Actors, Effects. By default, the image's origin point, meaning the point from which it grows, shrinks, and rotates, is set to its top left corner. Use the Set Origin block to change that as needed. The blocks under Change Images are used to manipulate your images. Before we go through the available blocks, a few things you have to know. Each change in the image is permanent. If you draw text once, it will stay there. If you change an image, the change will appear in all instances of that image you create. Now onto the blocks. Fill Image completely fills your image with the given color. Be aware that this also goes over transparency. Draw Image onto Image does exactly that. You pick one image and draws that onto another at the specified position with the specified blend mode. This can also be used in a way analogous to brushes in drawing programs. If you're using a HUD image with game information, you can draw actor images onto a main canvas to organize everything in a single image. Draw Text onto Image does a similar thing, but drawing text instead. It can be used just like the text block in the Drawing tab of the palette, and all the tricks I explained in my drawing video can be used here as well, with the exception that the font used is specified in this block. It is here that it's important to remember that changes in images are permanent. If you constantly draw an attribute that changes, you will get undesired results as the drawings stack up. I'll explain how to deal with that shortly. Red, green, blue as color allows you to get a color based on the RGB values. This means you can use numbers and get a color, and is used quite a bit in my special effects behaviors. Note that the reverse operation is not straightforward. If you pick a color and try to convert it into a text or number, you won't get the RGB values. Instead, you'll get a number containing the transparency, red, green, and blue values in a different format. clear image allows you to erase the entirety or parts of the image. The clear or retain image using image works like the draw image onto image. When set to clear, it clears a part of your image using the non-transparent pixels of your other image. Again, it would be like using a brush in a drawing program as an eraser. Retain does the opposite. The transparent pixels will be the ones doing the erasing, and the non-transparent pixels will keep the image. Retaining and transparent section of your image will paint it black. It is important to note that the clear or retain block is more resource intensive. You should be fine if you are using that block once in your image, but when you have to do it constantly, the bigger the cleared section, the bigger the performance impact. Experiment and try to control the use of that block to the best of your ability. The transform image blocks allow you to apply the actor effects to the image, but note that you cannot remove effects from an image, unlike with actors or image instances. You can also flip your image horizontally and vertically. The swap color block switches one color for another. Another reminder that changes to an image are permanent. If you're swapping multiple colors, any previous change can be affected by your new color swap. Lastly, pixel operation allows you to add pixels to your image and get the color of specific pixels. If you are doing several of these operations at once, either by multiple uses of these blocks or through loops, use the batch draw block beforehand for better performance. The get pixel block returns a color, which you can use to set a color attribute, for example. While this doesn't return an RGB value, as explained previously, one specific check can be pretty useful. If the resulting number is 0, it means there is no pixel there, i.e., it is a fully transparent pixel. Previously, I showed how constantly drawing and updating value could leave a jumbled mess. The same happens if you constantly draw the image of an actor that has multiple frames of animation, with the frames overlapping. To get around this, you need to create an updating image. This is a term I made up and refers to the following. Using a drawing or other recurring event, you reset your image to a clean state before drawing or changing elements. This makes the image function in a similar way to the regular drawing blocks, with the difference that, when you stop drawing, the last state is kept. Now, let's go over a few ways you can reset your image to a clean state. First is clearing the entire image. You do that at the beginning of your recurring event. This means you have to draw everything every time. If you are worried this can cause performance issues, you can use a boolean and a do-after to change the frequency of the drawing updates. Second is clearing only the part of the image that updates. This is more specific and can be used in a case-by-case basis. It's not a method I personally use. Third is to store the state of your image before the updating values in another image attribute, and draw the stored image on top of your original image before drawing the changing elements. That means all the initial drawing must be done only once in a separate part of the behavior. The WhenCreated event is a good candidate for that. In this example, I'm storing an image filled with white to reset to. Don't be afraid of using multiple image attributes. You can think of multiple images as layers in programs like Photoshop or Inkscape, for example. Truly elaborate drawings using those programs can end up with dozens, if not hundreds of layers. Because of that, using a map attribute to store multiple images can be useful to keep your attributes organized. At the end of the Images article on Stencylpedia, the Destructible Terrain Challenge hints that you can create your own collision detection. I won't provide you with the full solution for that challenge. What I can do is show you the tools needed to get started on your own collision system. The key lines in the Get Pixel block. As mentioned earlier, if this block returns 0, it means that pixel is transparent. By comparing your actor's position to the pixels in an image, you can stop movement when a non-transparent pixel is found, creating a pixel-perfect collision shape. As a more concrete example, in my semi-solid position behavior, an actor's terrain is generated by looping through each pixel along its width, and going down until a non-transparent pixel is found, using nested loops. The height of each pixel found is added to a list, forming a list of points along the surface or the top side of the actor. Here, I've slowed down the surface generation code so you can see how it works. This results in a list with all the points along the actor's surface. The player can then get that list when it collides with the actor, which is a sensor, and adjust the position as needed. Extrapolate on this idea to make a more elaborate collision system of your own. That's it for this quick tip. The Image API is considered an advanced topic, with its own learning curve, and too wide an array of possibilities that it's often overwhelming. I hope this video helped you understand them better, and the examples provided can inspire you to make more use of images in general. I'll leave links in the description if you want to learn more about Stencyl, my itch.io page to get the resources I've made, and to my Twitter if you want updates on what I'm currently working on. Leave a comment if there are any Stencyl topics you want me to cover. Suggestions are always welcome. Thank you so much for watching.